Okay, so this video is going to be on lesson 2 of Trig 2. So we're doing trig equations, solving trig equations and trig identities. And this is the last lesson on solving trig equations. What I want you to write just at the top of your page is I'm going to show you the difference between what we did in lesson 1 and then what we're going to do in lesson 2. So in lesson 1, which is what we did yesterday, what we were doing was solving first degree trig ratios. And I'll just give you an example of what we did yesterday. So solving first degree trig ratios. So an example that we did yesterday that's a first degree was 3 secant, it should be 3 secant x minus 5 is equal to 0. So this is a first degree trig ratio, and the reason why we call this a first degree trig equation, is because the degree on the x is a degree 1. So what we did yesterday was if we had a first degree trig ratio, we either graphed this. So I said, okay, we could punch this into y1 and we could look for the zeros of the graph, or what we did was we isolated secant. Right, so the most common way when we do this algebraically is to isolate secant. So you'd have brought the -5 over to the right and divided by 3, and we would have gotten secant of x is equal to 5 over 3. We would have then changed that to cos, and we would have had 3 over 5. And then what we would have done is the cast rule to find out which two quadrants is cos positive. And then we would have, from there, found the reference angle. So we would have done the inverse cos of 3/5. And that would have given us our reference angle. So lesson 1, like I said, was solving first degree trig ratios. What lesson 2 is, so lesson 2 is on solving second degree trig ratios. And what that means is there's going to be a square for lesson 2. So an example that we're going to be solving today is something like this. Sine squared x minus 3 sine x is equal to 0. So we're going to be doing the exact same methods as yesterday, except we're going to be dealing with squares. Now from 10C and 20-1, when you had a squared, what we had to do to get zeros is we had to factor. So today's lesson, before we solve, we're going to first have to factor. And then the methods of factoring that we learned from 10C, they are GCF, PSA 1 or 2. Okay, so I always call them PSA 1 or 2. The book calls them inspection and decomposition. And then the last method of factoring that you need to know for this course is difference of squares. And we're going to review these 3 types before we even get into this lesson right now. Okay, so again, lesson 2, it's going to have second degree trig ratios. If you see a square in your equation, you must factor and you choose which method of factoring you're going to do. And then after we review the methods of factoring, I will show you how to solve, which is what we did yesterday. So it's going to be a review of yesterday. Okay, so question or class example number 1 says factor. So remember there's those 3 types of factoring, and they are GCF, PSA 1 and 2, and difference of squares. So you've never factored with a trig ratio, with sine, cosine, or tangent. So what I'm going to do, just until you get used to this, I'm going to substitute this tan of A out, and I'm going to pick a different variable, and I'm going to choose the variable y. So I'm going to take this tan of A out, and I'm going to put a y in its place. And the reason why I do that to start with is because some students wouldn't be able to see how to factor this right away. But if I gave you a an expression that looked like something you would have seen in 10C, a lot of you would have said, okay, I could factor this. This would be factoring by GCF. So the GCF would be 4. And how you factor by GCF is you divide each term by that GCF. The GCF goes in front of the bracket, and the answer after you carry out the division goes in the bracket. So 8 divided by 4 is 2y plus 1. I have just factored this expression. There's 2 factors. One of my factors is 4, one is 2y plus 1. What I must now do, though, is remember that my original expression did not have a y in it. So I've got to take that y out, and I've got to re-put back in what I substituted y to be, which was tan of a. So the actual answer, once it's factored, is 4 multiplied by 2 tan of a plus 1. And this is your expression, your trig expression completely factored. Okay, we're going to do the same thing up here. So I'm going to substitute, I'm going to pick a variable that's different than what I see. And I'm going to pick the variable a. So I'm going to say, let a equal to sine of x. So what I'm going to do is I'm going to take the sine of x out and I'm going to put an a in so that we could see easier how to factor this. So it's sine squared of x, so that would be a squared minus 3a. So again, whenever you see a sine, right, this one was squared though. So whenever you see a sine, you take that out and you substitute in for a variable. If I said, well, how would you factor this? It's again factoring by GCF. The GCF would be an a. A comes out, and the second factor, once I undergo the division, would be a minus 3. And then at the end, I say, okay, I made up this a, so I've got to put back in sine of x. So this a is a sine of x, and this a is a sine of x minus 3. Once you get more comfortable with this, and you could do this substituting this entire time if you want, I will often only substitute for trig ratios because I just find that the easiest way to see. Some students will be really good at this and will say to they'll say to themselves, okay, I've got 2 sines here and 1 sine here, and they'll just do this. I could take out a sine of x from each side. The sine of x goes in front of the bracket. Sine squared divided by sine would be there's 1 sine left, minus sine over sine will cancel, and you're left with the 3. So if you're able to see that and you don't need to substitute out a different variable, then that's totally fine. Let's do the same thing though with the letter. So let's let a equal sine of x. So here, that's the variable I'm going to take out, or I'm going to put in the variable of a. So that would be 4a squared minus 1. If you saw this in 10C, and I said, okay, how would you factor this? Because there's no GCF, right? Between a 4 and a 1, I can only factor out a 1. This is the difference of squares. So you just have to be really good at recognizing difference of squares. Difference of squares, what it is, to review, it's 2 terms separated by a minus, and each of these terms could be square rooted. How we factor a difference of squares is you set up 2 brackets, and you say to yourself, what's the square root of 4a squared? 2a. That goes at the beginning of each bracket. What's the square root of 1? So the square root of 1 is just 1. And then a difference of squares, one bracket gets a positive, or one factor gets a positive, one factor gets a negative. So that's how you do a difference of squares. And then at the end, I got to do the same thing. My a's come out, and I substitute back in what a is equal to, which is the sine of x. So 2 sine of x plus 1 is one of my factors. 2 sine of x minus 1 would be your answer. Okay, now we're going to do a review of a PSA 1, which is inspection. So this guy will be a PSA 1 because there's an invisible 1 here. And this one's a PSA 2, which is decomposition. So for this one, let cosecant equal A. So I want you to right now take a minute and just, what would this expression become if I take out these cosecants and I put in an A? So hopefully you get A squared minus 3A minus 28. Set up your chart, product, sum, answer. And remember, you're always looking for, this is your A value, this is your C value. So you're always looking for the product of negative 28 times 1. So we're going to be looking for what two numbers multiply to negative 28 and sum to negative 3. So I'm just going to give you that answer. So the numbers that multiply to negative, so you're really just looking at what numbers multiply to negative 28. And then you're going to figure out, well, from those numbers, which one sums to 3. It's going to be 4 and negative 7, right? 4 times negative 7 is negative 28. 4 plus negative 7 is negative 3. If it's a PSA 1, then it's easy. You just put your variable at the beginning of each bracket. One variable is going to get a plus 4, and one variable is going to get a negative 7. So those are my two factors. And then at the end, we take out our A and we substitute back in cosecant of x. So one of my factors is cosecant of x plus 4, cosecant of x minus 7. And that would be your answer. Okay, to review a PSA 2 question. So this time we have a cos. So let's write let A equal the cos of x. So rewrite this question first of all. What I want you to do is rewrite this first of all, taking out your cos of x and putting in A's. Then I want you to set up your chart. See if you're able to set up this chart and at least get this correct. Like, what's the product, what's the sum? And it should actually be very easy to figure out. You could do it in your head what the answer is. And then I'll review how to do decomposition, which we did in polynomials, so it shouldn't be that much of a review. So hopefully you have 2a squared plus 7a minus 4. Okay, the product, it's always the first term times your last term. So it's always this leading coefficient times the constant. So negative 8. The sum is always that middle term, 7. So the two numbers that multiply to negative 8 and sum to 7. So it's going to be a 1 and an 8. And which one is negative to get the 7? This guy would be negative. Okay, PSA 2 is decomposition. What we are decomposing is this middle term. So you say to yourself, how could you break down 7a using this answer? Like, how could I use this answer to get 7a? Well, negative 1a plus 8a. That's how you decompose 7a by that answer. Bring down this negative 4. Bring down that 2a squared. So decomposition always has 4 terms. And then what we do for decomposition is you always split those 4 terms in half and you group factor. So from these first 2 terms, what you could factor out is an a. And between a 2 and a 1 could come out. So just basically a 1a. And I'm just going to write a. So whatever comes out goes in front of your bracket and your answer goes in the bracket. So that would be, what would that be? 2a minus 1, because the a's will cancel. Then you go to the right-hand side. Between an 8 and a 4 could come out. On the right-hand side, you must always tell me the sign. So in this case, it's going to be a positive 4. And the answer goes in the bracket. 8a divided by 4 is 2a. Negative 4 divided by positive 4 is minus 1. What I like about PSA 2 is these two brackets is your check. If these two brackets are the same, you did your factoring correctly. So we did it correctly. So factor out that bracket, one of those brackets, 2a minus 1. So that's gone. And then your remaining factor is what's left over. You put it together. So a plus 4 is remaining. And then from here, we are done. Once we substitute back in what a was equal to, which was cos of x. So my final answer is 2 cos of x minus 1, cos of x plus 4. So even though we haven't done any solving yet, for this lesson, unless you could factor, you won't be able to solve. So you must be able to do all 5 of these in order to be able to do this lesson. If you can do these 5, you will be just fine with this lesson, because it then goes into what we did yesterday. Okay, so we're going to do a big review as well of what we did yesterday. Class example 2. Consider this equation. Use a graphical approach. So what we're going to do is they give us this equation, which is a second-degree trig equation. In class example number 2, I'm going to show you how to take this exact equation, and we're going to find the answer graphing it. And then in class example 3, we're going to take this, again, exact same equation, and we're going to algebraically solve it. So how I want to solve this one, graphically, we could do one of 2 methods. I could bring everything to the left, and we could do the 0 method, or we could do the intersect method, which I look at my equal sign, and I'm going to type the left-hand side of my equal sign into y1. I'm going to type this into y2. Okay. They don't give us a graph to look at, so what we've been doing is like looking at a graph to figure out what the scale is, but they give us a hint right here. So what we're going to change our window to is we're going to change our window. We're going to have a minimum of 0, a maximum of 2 pi. And then for the scale, you guys, if it's in radians, what you want to choose for your scale is they often choose pi over 6, pi over 4, or pi over 3. One of these is often the scale. So it really doesn't matter which one. They haven't told us, right? So I'm just going to choose a scale of pi over 6. So let's just write pi over 6. That's a common scale. Each hatch mark would be worth pi over 6. For my y's, now a sine graph goes from 1 to -1. So what you want to do is you want to extend your window like above 1 and below -1. So we could adjust our window if it doesn't look good, but let's try -3 to 3 and then have a scale of 1. So take out your calculators. Let's punch this into y1. Let's punch this into y2. And let's use this as our window. And we're going to check what the intersect is for our answer. Okay, so go to y is equal to, and clear what you have. Make sure that your calculator is in radian mode or you get this wrong. 2 sine squared x. How you type that in is 2 sine. You got to put the x. You must close your bracket and then square it. So that's the same thing as 2 sine squared of x. That's what they want in y1. In y2, they want 1 minus sine of x. And then we've got to get that window in there. So 0 to 2 pi. And then I'm just going to double check pi over 6. I'm going to just type in pi divided by 6. I'll do my scale. Let's go from -3 to 3. And a y scale. We could do 0.5 or we could just do 1. So let's see how this looks. Okay, so we just know that this is 0 to 2 pi. I didn't need any actually negative y's here, which is fine. The solutions when you have a y1 and a y2, the solutions are the intersects. So this is a solution, that's a solution, and that's a solution. So one thing I just want to quickly show you before we find the intersects is it says give solutions as exact multiples of pi. So that's where we're going to find what the intersect is, divide that answer by pi, and math one fraction it. So see if you're able to do that. I'm going to find this solution with you, and then I'm going to pick 2 different people to give me these 2 solutions. So let's find this one together. So second function, calculate. Oh, I think there might have been one. I wonder if this is the one that doesn't give me a nice answer. So go close to the intersect and you hit enter 3 times. Enter, enter, enter. So I get that number there. Let's see if this one works. So quit, and I want to get that x value. So the solution was the x coordinate. I want to divide that answer by pi. Okay, this one works. And then I want to math one fraction it. I think all 3 work nicely. I don't know why that didn't change, but that should be 3 over 2. So this answer here, or on the graph, this intersect is 3 pi over 2. So I'm just going to write x is equal, actually I'll write that one last. So we've got the first answer, our second answer, and then 3 pi over 2. So again, just take a minute, see if you could find this one and this one. And then I'll pick a couple different people. Okay, Brenna, did you get this answer yet? Or this one?
I am working on it.
Sure, which one are you working on, Brenna? Okay, I'll give you a minute and then you could tell me once you got that guy.
All right, I got 5 pi.
Yes. Oh, Brenna, did you do this one?
Oh yeah, that's the one I meant. Sorry.
The second one? Okay, 5
Yep.
pi over 6. So that's correct, 5 pi over 6. And Angel, do you have this first one done? Okay, maybe Angel, I'm not sure if you're there. Maria, do you have the first one done?
No, I actually got really confused, so I'm sorry.
Okay, no worries. Angel, sorry, what did you say?
Sorry, Mrs. King, what's the
Do you,
question?
do you have that first intersect done? So did you calculate what this one is?
Oh, yeah, but it's in decimal.
Okay, so take that decimal, divide it by pi.
Oh, okay.
So you guys, second function, calculate. So divide it by pi, and then math one fraction it. And what do you get, Angel?
Huh?
So was that your decimal?
Yeah.
Okay, so let's see.
I
So you
got
take that.
0.166.
Okay, so let's see. And then did you math one fraction that answer?
Yeah, it's still decimal, Mrs. K.
Oh. Should be 1/6.
Oh,
that
I rounded up, my bad.
Okay, yeah, so you just take that exact decimal and then divide that number by pi. Whatever this is, you then math one fraction that, and you should get 1/6. You have to remember tack on a pi because they wanted it in exact pi radians. So the third answer is going to be 1 pi over 6. So those are our three solutions. If I look at my unit circle, so one of my solutions was right here at pi over 6. One of my solutions is up here at 5 pi over 6. And one of my solutions is down here. And the only reason why I'm looking at my unit circle is because they want the general solution, which means like, what are all of the possible solutions that could land at the same coterminal arm as pi over 6? So I'm just making sure that two of my solutions don't land on a straight line, right? And they don't, because pi over 6 and this guy make a V, and then there's this one down here. So in order to do the general solution, how I get all the possible solutions in the domain of XER is I take this answer and I just keep simply adding or subtracting 2 pi radians to that to get the general solution. And I'm going to do the same to each one of these answers. So for B, state the general solution to the equation. So what we're going to do is we're going to write X is equal to, write your first answer. And to that, we're going to add 2 pi n. We're going to take our second answer. And to that, we're going to add 2 pi n. And we're going to take our third answer. And to that general solution, we're going to add 2 pi n. And then at the end, I could say n belongs to the element of integers. And that's just giving all solutions in the domain of X belongs to the set of real numbers. Okay, for class example 3 now, let's do this exact same equation. We want to get these exact same 3 answers, but let's do it algebraically. So if you have your unit circle, make sure that that's available because the unit circle is what you want to look at if you're able to. In order to solve this algebraically, you need to bring everything, because it's a squared, right? So whenever you see a square, you say to yourself, I have to factor. When you factor, everything needs to go to one side of the equal sign, and you always bring everything over. We want whatever our sign squared is, we want this to be positive. So what that means is I'm going to bring this and this to the left-hand side. So I'm going to get rid of this negative sign of X by adding sign of X to both sides. And I'm going to get rid of this 1 by subtracting 1 to both sides. And then what I have is I have 2 sine squared of X plus sine of X minus 1 is equal to 0. When we solve, when you bring everything over to the left-hand side, you must put a 0 here. So now from here on out, for these questions, when we're going to be solving, if you drop this 0 at any point, you are going to lose a mark for that. You can't drop that 0. So then say to yourself, okay, what type of factoring would this be? Is this a PSA 1? Is this a PSA 2? Is this a difference of squares? This would be a PSA 1, no, sorry, PSA 2 question. Let's take out our sign and let's put in an A. So 2a squared plus a minus 1 is equal to 0. So again, don't drop that 0. We now need to factor this by decomposition. So I'm looking for what gives me the product of -2 and a sum of 1. So that answer is going to be, the only two numbers that multiply to 2 are a 1 and a 2. And in order to get a 1, this guy has to be negative. Okay, this is decomposition. So break down that 1a and say to yourself, how do I use this answer to get a 1a? -1a plus 2a. That's how you get a 1a. Bring down that -1, bring down that 2a squared. Decomposition or PSA 2, you always get 4 terms. Break those 4 terms in half and group factor. Okay, so what I take out from here is a 1a, and I get 2a minus 1. And what I take out from here is I could take out, between a 2 and a 1, I could take out a 1, and it's going to be a positive. It's whatever sign that is. And then what does that give me? 2a minus 1. I've got to put that 0 so I don't drop that 0. Okay, so from here, what we do is I check that I did this correctly. And I did, because those two factors are the same. So my second factor is a plus 1. Don't forget, keep bringing down that 0. Now what I have to do is I sort of have 2 more steps. So second thing I need to do is I need to take out the a, and I put in what a was equal to, which is sine of x. So one of my factors is 2 sine of x minus 1. And my second factor is sine of x plus 1. And that's equal to 0. Okay, so the whole reason why we spent all that time in class example number 1 reviewing how to factor is to get to this step here. And now what we're going to do is we're going to solve. So this goes back to math 20-1. And once you have your factors, your 2 factors, you set each factor equal to 0 and you solve. So now we're going back to what we did in lesson 1. So I'm going to write this factor here. And I'm going to set that equal to 0. I'm going to write this factor. And I'm going to set that equal to 0. Each one of these I could now solve, because the point of factoring is to get a first degree trig expression. And that's what we did yesterday in lesson 1. We solved first degree trig equations. So you got to isolate your sine of x, bring that 1 over to the right hand side. So one of my answers I'm going to look for is, where is sine of x -1? Over here, I'm going to do this in my head, so I'm going to do it in one step. I'm going to bring that -1 over, and I'm going to divide by 2. So this answer, the second one, is going to be sine of x is equal to 1 over 2. Okay, sine, let's start with this one. Sine of x is equal to -1. So where is y? Because sine is y. where's y negative 1? So if you look at your unit circle, right here, that's the only place where y is negative 1, and that is 3 pi over 2. That is one of my answers. So this one is done. My other answer, now I've got to go over here. Where is sine 1/2? So before I find this one, just remember, according to the cast rule, sine is positive, because this is positive, here and here. So I'm going to have two different answers in quadrants 1 and in quadrants 2. So I'm going to go and I'm going to find where's y 1/2 in these two quadrants. Right here and right here. So I've got 3 pi over 2 as an answer. I've got pi over 6 and 1 pi over, and 5 pi over 6. So pi over 6 and 5 pi over 6. Those are my answers factoring or algebraically. So let's check on our previous page where we did this question graphically. I'm going to be looking for pi over 6, 5 pi over 6, 3 pi over 2, and see if we got that answer. Pi over 6, 5 pi over 6, 3 pi over 2 is my answer. So then again, they want the general solution. So remember, you're just for general, I'm just making sure that it doesn't make a straight line. So that's obviously not a straight line. And then this guy's the solution as well. None of these are straight lines. So if they're not straight lines, to write the general, you just take each solution, and every time I add 2 pi n's, I'm going to get back to that solution. So for B, again, the general solution is pi over 6 plus 2 pi n. I had 5 pi over 6 plus 2 pi n. And I had 3 pi over 2 plus 2 pi n. And we could go in the clockwise or the counterclockwise direction. So that's why I say n belongs to the element of the integers. Okay, so that's how we do that question there. Remember, I could have done this like without the unit circle. So remember how I taught you yesterday as well, like the other methods. That's why we spent so long yesterday. I could have done this by finding the reference angle. So remember, I could have done this. You don't have to write this down. But the inverse sine of 1/2, that would give me my reference angle, which is going to be pi over 6. Like that's, if you did that on your calculator, you would have gotten pi over 6. And then you would have said, okay, that pi over 6 is in this quadrant, and it's in this quadrant. So you would have put pi over 6 here. And you could have subtracted pi minus pi over 6 to get 5 pi over 6. But if you're able to use your unit circle, it's faster. Use it. Okay, class example 4. So we've got 2 class examples left. Use an algebraic procedure, so that means factor, to determine the roots of the equation on the given domain and write the general solution. All right, this one here, let's take out sine squared of a, and let's choose a variable for that. So one thing, I don't like choosing the same variable that's in my initial equation. So I'm not going to choose the letter A. I'll choose the letter B. So 4b squared, right? Because I'm going to take out that sine of A, or if you want, I'll choose y. So 4y squared minus 1. If I said factor this, two terms separated by a minus. This is a difference of squares. Set up your two brackets for a difference of squares to give you your two factors. And the square root of 4y squared is 2y. Square root of 1 is 1. One of your factors gets a plus. One of your factors gets a minus. From here, we're done. Let's take out our y and put in sine of a. Okay, what we need to do is remember when we're solving, always carry down that 0. Now you can set each factor equal to 0 and solve. So if you want, you could do that. Like you could write 2 sine of a plus 1 equals 0, 2 sine of a minus 1 equals 0, and then solve it. Or hopefully a lot of you can just do this in your head. So if this was equal to 0, right? And I said solve for 0 or solve for sine of a, you'd bring that 1 to the right-hand side and you divide by 2. So this would be sine of a is equal to -1/2. And this one, if I set this factor equal to 0 and I solve for this, get rid of that -1 and divide by 2. Sine of a is equal to +1/2. According to my cast rule, where is sine negative? Here and here. Where is sine positive? Here and here. So we're going to have 4 different solutions. So see if you could look at those of you that have your unit circles with you. Look at your unit circle. Sine is y. So you're going to look for where is y positive in these two quadrants. So where is y 1/2? So if I'm going to do the positive first. So where is y 1/2 in these two quadrants? So I've got answers of pi/6 and 5pi/6. Where is y negative in these two quadrants? 7pi/6. And this guy. What is that? 11pi/6. Okay, those are my 4 solutions. So box that in. The general solution. Okay, so again, on a test, this is going to separate the students that like really get this versus those who don't see it as much, because I'll find that in the general solution when people write their general solution. So it's always helpful to do a little sketch of your unit circle and then to draw lines. So that's a solution. That's a solution. And you might say to yourself, well, right now, that's not a straight line. But this is a solution. And this is a solution. So those of you that start to get really good at this, what you're going to see is that these two fall on one line that could spin and make a propeller, and so do these two. So what you have to do to write your general solution, let's just look at this blue line. Remember, you always take the smallest principal angle, which is pi over 6. And to get to here, which is another solution, what do you have to add? Well, if it's a straight line, you just have to add multiples of pi, right? So you're going to add pi n. And then again, from here, 7 pi over 6, if I add another pi, I get back. And if I keep adding pi, I'm going to stay on this blue line. So that is one of my general solutions. And I say n belongs to the element of integers. Now I have to take care of this line. So between 5 pi over 6 and 11 pi over 6, you always choose the smaller of the two, which is 5 pi over 6. What do you have to add to get to 11 pi over 6? It's a straight line. Every time you have a straight line, the only thing you have to add is pi. And you tack on an n. N belongs to the element of integers. And each time you add an n, you're going to be going back to that red line. So that's how you would do the general solution for 4a. And again, this really separates, I find, like standard of excellence versus just acceptable standard is what it would be called. Okay, let's do this 4b, and then we'll do number 5. Okay, tan square root of x plus tan of x is equal to 0. So let's choose the letter A. So a squared plus a is equal to 0. How would you factor this? It's not a PSA 1 or 2 because it's not 3 terms. It's not a difference of squares because there's not a negative here. This would be a GCF. A divided by A cancels, and it just gives you a 1. Hi, Kyle. I just saw your message, so you'll probably be lost, but I will upload the video at the end for you. So just write down where we are, but then after you could watch the video.
Okay, thank you.
You're welcome. Okay, so that is equal to 0. Take out your a at the end, and let's put back in our tan of x. And then what we do is we set each factor equal to 0. So that factor is equal to 0 and this factor. Sorry, that second one would be tan of x plus 1. Okay, so this one is solved. We're going to find, well, where's tan 0? And this one, we're going to solve this guy, isolate the tan, -1. Okay, sometimes students have a harder time with tan looking at the unit circle because tan is y over x. So the first thing I'm going to do is if you struggle with tan, one thing that you could do is you could do the method that we did yesterday and you could find the reference angle. So for solving this one, the inverse tan of the absolute value of -1 is 1. And what I'm going to do just to, instead of worrying about radians, even though they do want my answer in radians, just to be able to visualize this, I'm going to change my calculator to degree mode. And I'm going to see, well, what's the reference angle? So second function tan of 1, and that's 45 degrees. So the reference angle is 45 degrees. If I go back to my unit circle, because we're in radians, 45 degrees is the same thing as pi over 4. So the reference angle is pi over 4 radians, and that's my reference angle. They want to know, we need to figure out where tan is negative. So according to my cast rule, tan is negative in quadrant 2 and in quadrant 4. So quadrant 2 and quadrant 4, I'm going to have answers. So in quadrant 2, if my reference angle is pi over 4, what is my angle in standard position? So here's that 45-degree angle. So they want to know what this is. So you could have done pi minus pi over 4, and it would give you this answer, 3 pi over 4. Okay, so that's going to be one of my answers. And you guys remember, tan is y over x. So if you took this number, the y, root 2 over 2, and you times it, because we're not going to divide by a fraction, we're going to times it by the reciprocal of this. The reciprocal of this would be negative 2 over root 2. That's where you get that negative 1. Root 2 over root 2 cancel. Negative 2 divided by 2 is equal to negative 1. So one of my answers is going to be 3 pi over 4. The other answer, what did I say it would be in quadrant 4? So in quadrant 4, this one right here, if you divide y by x, you would get that negative 1. So one of your answers is going to be right here, 7 pi over 4. Okay, so x is equal to 3 pi over 4. And then 7 pi over 4. And again, if you put that reference angle of pi over 4 here, and you did 2 pi minus pi over 4, you get 7 pi over 4. So those are two answers. Now we have to look at our other factor, which was this guy. Where's tan of x equal to 0? So I tend to only do this for tan to show students because sine and cosine, it's easy, right? You just look for the y or for the x. The reference angle would be 0 degrees. Okay, so what that means, I'll show you what that means. So 0 degrees, which is my reference angle. Okay, if I go back to my unit circle, we're looking for where tan is 0. So let me just clean up this for you guys. I'll clean up this. Okay, so 0 degrees is right here. Tan is y over x. 0 over 1 is equal to 0. So this is a solution. But then let's check this. That's x and that's y. Y over x, 0 over negative 1 is 0. So this is a solution. So the other solutions that I have are 0 radians and pi radians. To write the general solution for this, okay, so let's first write the general solution for this. So hopefully you see that this lands on a straight line. So again, if it lands on a straight line, we're not adding 2 pi n to each answer. You're taking your smallest, which is your principal angle, and to that number, in order to get to 7 pi over 4, you just need to add multiples of pi. So one of my general solutions is x is equal to 3 pi over 4. Pi over 4 plus multiples of pi. Okay, so that's one of my general solutions. My other general solution, so this one is a bit more complicated and you sort of just have to memorize this one. So this again is a straight line. And we don't write 0, like 0 times something, because that would be 0. So you're going to choose pi. And how we write this one, if you have pi, instead of adding pi n to it, what we just do is if your answer is pi and it falls on a straight line, you just do pi n. N belongs to the set of integers. Because pi times 1 would take you here, and then pi times 2 would take you here. If I put a 3 here, 3 pi would go back here. 4 pi would go back there. So this is how we write the general solution. So just make sure that you are comfortable with that. Yes. Yeah.
Or do you want them?
Sorry, say that one more time, just because you were cutting out.
Do you put them together to one line, or do they have to
No. Oh. Because there's 2 general solutions, like you could put it in one line, but like technically these can't be combined, right? Like this red line would be one general solution, and then you would have to put this green line on a separate general solution. So I would just separate it like this.
Oh.
Yeah, just so that in your mind it doesn't get confused, have these separated.
Okay.
Yeah.
Thank you.
You're welcome. Okay, let's do, so I know this is a lot, but we're going to do 2 more. And normally I don't do this, but let's do this one just to practice. Okay, determine the zeros of the following function. So we'll do A and B. Zeros means take that f of x out and just substitute it in a 0. So 0 is equal to cosecant squared of x minus 3 cosecant of x minus 28. Let's, we're gonna have to factor this. So let's take out our cosecant and let's just put it in A. Okay, say to yourself, is this a PSA 1 or is this a PSA 2 question? This would be a PSA 1. So we're looking for what gives us the product of negative 28 times 1, which is negative 28. And what gives us the sum of negative 3. So numbers that multiply to 28 are 1 and 28. It's not going to work. 2 and 14 is not going to work. 3 is not, 28 is not divisible by 3. 28 divided by 4 is 7. So let's check if 4 and 7 work. And in order to get a -3, it will work if my 7 is negative. PSA 1 is you just set up your two different brackets, put an A at the beginning of each bracket. 1A gets a +4, 1A gets a -7. We are done factoring. Now I just need to substitute out that A and put back in the cosecant. So cosecant of x +4, cosecant of x -7. Okay, let's let each of our factors equal to 0 and solve. So this factor, if I set it equal to 0 and solve for cosecant, would be cosecant of x is equal to -4. And this factor is going to be cosecant of x is equal to 7. Now, I don't know where cosecant is, right, on my unit circle. So I'm going to do the reciprocal trig ratios. I'm going to put each of these over 1. And cosecant is reciprocal for sine. So I'm going to have the sine of x is equal to the reciprocal of this, which is 1 over -4. And this one would be the sine of x is equal to the reciprocal of this, which is 1 over 7. Okay, hopefully, what I'm hoping is that you can see that these are numbers that are not the nice points on our unit circle, right? So this would be on our unit circle, but it's not any of these nice coordinates here. So we're going to look back at the question, and it says answer to the nearest degree, which means that we're going to have to round. And we're going to have to do the algebra for each of these because we can't look at the unit circle. So let's find the reference angle for this one and the reference angle for this one. So sine, inverse sine of the absolute value of -1/4 is 1/4. And I need to be in degree mode. So on my calculator, I need to be in degree mode. And I'm going to type in the second function sine of 1/4. Gives me a reference angle. They want it to the nearest degree. So that would be 14 degrees would be my reference angle. Why does it say? Oh, okay. So I'm going to show you something interesting. So we're going to write 14 degrees. And that's my reference angle. And then what I need to do is I need to find, okay, according to cast, where is sine negative? And I'm going to put a check mark here and here. So normally, you guys, what we would do is we would have two answers. So I'll show you what we would normally do and then why we're not going to do this. Normally, I would say, okay, one of my answers is right here. If this is 14 degrees, it would be 180 plus 14, right? And then I would say I've got another answer in quadrant 4. So I put my 14 degree reference angle in quadrant 4. And then normally I would say this rotational angle, how you calculate that is 360 minus 14. But what's special about this question is they gave us a domain restriction. So that's what class example 5 is. The domain restriction, they only want answers less than 180, greater than 0. That's what they want, less than 180, greater than 0. So if I go back down here, what that means is 180 degrees is right here, 0 is right here. If they want less than 180 but bigger than 0, they want answers in quadrants 1 and 2. So we know that for like this particular one, the answer was in quadrant 3 or 4. So what that means is that there's no solution. I would only give these two answers if this was my domain. Less than or equal to 360, greater than or equal to 0. But because they changed this to 180, they restricted my domain and they want only an answer in quadrant 1 or 2. So there is no solution for that first one. Okay, let's check this next one and let's see if it's within quadrants 1 or 2, because then I'll have answers. So to do this one, to find out the reference angle, we're going to do the inverse sine of 1/7. And let's find out what that reference angle is. So on my calculator, second function, sine of 1 divided by 7. And I get 8 degrees for this one. So 8 degrees is my reference angle. So then what I have to do is I have to say, okay, according to the cast rule, where is sine positive? Here and here. And that obeys the domain restriction. Because remember, my domain restriction has to be answers in quadrant 1 and 2. These are answers in quadrant 1 or 2. So I will actually have 2 different answers for this one. So now what I'm going to do is I'm going to put that 8 degrees in quadrant 1. And I'm going to say, what's that rotational angle? And that answer would be 8 degrees. Then I'm going to take that reference angle and I'm going to put that guy in quadrant 2. And I'm going to say, okay, well, what would this rotational angle be? And that would be 180 degrees minus 8, right? Would give me 172 degrees. So I've got 2 answers. They want me to use x. So x is equal to 8 degrees is one of my answers. And 172 degrees is the other answer. And they do not want general solutions. They just, if they're asking a question on like restricting the domain, that's all they want students to be able to do. If they wanted the general, it would be easy because this does not fall in a straight line. So I would take 8 degrees and I would add 360n, and then I would take 172 and I would add 360n. Okay, this last question is your standard of excellence question. And we're going to talk about this last one and what I'm going to do on the exam for this last one. Okay, so only seeing this one time is not enough. Or if you don't want to get the standard of excellence one right on the test, that's fine. You'll probably get all the other questions right. But those of you that are getting like the 90s and want to keep that, it's not enough to see this question just one time because of how crazy this domain looks. So my friend, Miss Carlitos, the one that you've been watching the podcast for, she actually does this different domain restriction in 1, 2, 3, 4, 5 different videos. And what I'm going to do on the exam, because it's next week and it should be in school, is I'm going to essentially just look through those 5 videos and do one of them for the test question. So you've got sort of 5 different opportunities to watch her videos to understand how this works, if you don't quite understand how I explain it. And each video is 3 minutes in length, so they're not long videos to do this. It's going to be a longer video, or it's going to be a longer example for me, unfortunately, because this is a PSA 2 question. She doesn't do any PSA 2. She keeps it nice and simple in order to do this. So this question is normally a nice, easy question, and then they do this crazy domain, which we'll deal with at the end. So let's just do this question how we normally would. And this, remember, they want the zeros, so you make that guy 0. This would be 0 is equal to 2 cos squared of theta plus 5 cos of theta minus 3. Let's change this out and let's put in a's. So 2a squared plus 5a minus 3. Hopefully everybody recognizes that this is a PSA 2 question. So we would set up our chart. We'd be looking for what gives us a product of -6 and sums to 5. 1 and 6 or 2 and 3. But this has to be negative. Okay, so it's going to be 1 and 6. And in order to get a positive 5, the negative would be at the 1. So it's a -1 and a 6. So let's quickly do our decomp. How do you decompose that middle term by this answer? How you get 5 a's is -1a plus 6a. Bring down that -3, bring down that 2a squared. Split this in half and group factor. A squared and an a, you could take out an a. Between a 2 and a 1, it's only a 1, so I'm just going to write an a here. That would give us 2a minus 1. Over here, between a 6 and a 3, you could take out a 3. And you have to take out a sign on the right-hand side. It would be a positive. Once you do your division, 6a divided by 3 is 2a. Negative divided by a positive is a negative. 3 divided by 3 is 1. My brackets are the same, so I'm going to factor out that bracket. And my second factor is going to be a plus 3. Because that joins together, and let that equal to 0. You could now rewrite this, take out your a, put in what a is, which is the cos of theta. So one of my factors is 2 cos of theta minus 1. My other factor is cos of theta plus 3. Remember, don't ever drop that 0. Okay, from here, what do I do? Each factor, set it equal to 0 and solve. So hopefully you guys are able to just do this in your head. That would be 1/2. And this guy would be -3. Okay, where I want to start is I want to start with this one. So you say to yourself, okay, -3, well, that's not like a nice number that I know of on my unit circle. So I'm going to figure out what the reference angle is, and something's going to happen on your calculator when you type this in. So the inverse cos of 3 is equal to, And for this one, we are in radian mode. So I'll clear this. I'm going to just change my mode to radian. And I'm going to type in the second function, the inverse cos of the absolute value of -3, which is 3, and I get an error. So what that means, you guys, is there's no solution. So if you get an error and you've typed everything in correctly, there's no solution. The reason, and you don't need to know this, but cos could never be a number bigger than 1 or -1. So that's why we get no solution for this. Cos of 1/2. Okay, so without looking at the domain restriction, what we would normally do is we would normally say, according to my cast rule, cos is positive here and here. I've got two different answers, right? And then normally I would say, okay, where cos is my x value, where is x 1/2? I would go to my unit circle and I would say at pi/3 and at 5 pi/3, right? So normally that's what I would do. If I didn't have a domain restriction, I would say my answers are x is pi/3 and 5 pi/3. Here's this domain restriction that they give us, -pi to pi. So I'm just going to write that down and I'm going to show you how you separate this. So -pi . Okay, if you see something like this, it's very difficult to visualize this in your head without separating this. How we separate this is into what's called, we rewrite this into what's called the positive and the negative domain. So what you do when you see something scary like this is you just rewrite this exact same thing. And I'm going to take out, let's say, this one, the left, and I'm going to put a 0 in there. So you're going to write this exact same thing, but I'm going to take this out and I'm going to put a 0 in there. So 0. So that I just copy down. And this is what's called, I separated it into what's called the positive domain. Then what I'm going to do is to figure out what the negative domain looks like, is I'm going to write this exact same thing, but this time I'm going to take this one out and I'm going to put a 0 in there. So I'm going to keep that -pi. I'm going to keep everything except I'm going to put a 0 on that side. Oh, sorry, that should be an x. Students, if they separate it, should be able to visualize. So we know that we've got an answer here and we've got an answer here, right? We've got two different answers. But now I've got to do it according to the domains. So according to this domain here, from x is less than pi greater than 0. So if this is 0 and this is pi, x is less than pi greater than 0 tells me I could have a solution within these two quadrants. And sure enough, it would be that guy there. So that answer, we said, where was x, because cos is x, where's x 1/2? If I go back up here, pi/3 is one of my answers. So I would say, I'm just going to erase this. Okay, so one of my answers is x is equal to pi/3. Now, this negative domain. They're saying x is less than 0, greater than -pi. So this is 0. Here's -pi. that means that I could pick an answer down here. And some students would say, well, yes, like I can include this C here, except, which is true, you can, except you have to say, well, what would that be going in the negative direction, right? So yes, I could pick that answer here, but what I have to do is I have to write that in the negative direction. So if I go back to my unit circle, this is an answer, but it's not 5 pi over 3. If I said, well, what would this be, right? What this would be, because if I go once around, that would be negative pi. If I go to here, that's negative pi over 2. This would be, if I go in the positive direction, this is pi over 3. So if I go in the negative direction, this would be negative pi over 3. So that's my second answer. And that's the answer that makes it a standard of excellence question, is that negative pi over 3. Okay, so those are your two answers for that question. Here is your homework. So your homework, if you want to start circling. So basically everything on the first page, except you don't need to do D. So on this page here, you would not be doing D and you would not be doing F. Okay. You would do number 2, which I think is graphing calculator. And you do number 3. Skip to number 7. So number 7 is what I was saying with, so for those of you that had written down those podcasts already, so those 5 podcasts, this is on domain restrictions for number 7. Number 8, I'll set up one thing for you. And number 10 and 11. Okay, so what I quickly want to show you before I shut off the video. So those of you that were going to watch these podcasts, I just want to show you where they are because it took me a while to find them. So I'm just going to show you that really quickly. So it says chapter 4, and it's like, it says lesson 1C, 3, 4, and then it says scroll to bottom. And I'll show you why I wrote that. So those of you watching this, so it's on chapter 4, which is the unit circle. And if you look at the videos for chapter 4, why do I say scroll to the bottom? Sorry, just let me look. 1C, 3AB, 4AB. 1C. Oh yeah, okay, so this is like not 1C, right? So once you get to chapter 4, if you scroll to the bottom, she then added in all of these videos. So it's under chapter 4, like I said, but it's at the bottom. So it was this one, 3AB, and 4ABC. I will upload the podcast note package for you, but you really don't need it at all, because if you look at the video, I'll just quickly show you, is all you would be writing down is this, right? So I will upload the podcast note package for those of you that like doing that, if those of you that wanted to print it. But again, you could still easily watch this video. Okay, it's a 4-minute video. And look at, it's that exact same domain restriction. So she'll do that same domain restriction a few different times. And it's going to be a very basic question. She'll do this question in 4 minutes. So that's how I would recommend doing that. And then let's quickly set up question 8, and then I will let you do this homework. And I will stop the video as soon as we're done with question 8, or set it up. So if you want to flip to question 8. So here's that domain again. Okay, so the only thing I want to do for this one is it says algebraically find the general solution. So that means we're going to be factoring. Whenever we have a squared, remember you want to bring everything to one side, and you always go to the side where the squared will be positive. So in this example, I need you to bring this to the left. So the only thing I want to write for this one, cosecant squared of theta. If I subtract this to bring it to the left, and then that minus 2. And then you're going to PSA 2 this. So that would be a PSA 2. This one, you want to go to the right-hand side because this is positive, right? That's what I care about. So if I bring that over, I'm going to have a 0 there. And I always want to write in descending order of, I want to put this first. So it's going to be secant squared theta. I'm going to subtract 3 secant from both sides. So I'll put that next. Minus 3 secant of theta. And then I've got that. This is a positive 2. This would be a PSA 1 question. Give your answer as exact values. Remember to do this on your calculator. Whatever your reference angle is, you divide that answer by pi, and then you're going to math one fraction. Is how you would do that question. So I'm just going to stop this recording.